Hello, this is the solution of worksheet section 3.3. So we will start with MCQ number 1. Here we have the function f of x, and it is given that f prime of 0 is equal to 1 and f secant of 0 is equal to -1. Then we want to find a and b using this information. So since we have information about f prime and f secant, we need to compute f prime and f secant at the point x in general, then apply at the point 0. So if f of x is equal to this function, then f prime of x is equal to is a number like any other number times cosine. Derivative of cosine is equal to minus sign, so it is minus a times sine x plus b derivative of sine, which is cosine, so plus b cosine x. And here when we apply at 0, so I will find f prime of 0. Remember that sine of 0 is 0 and cosine of 0 is 1, so I will have equal to b, and this will give me that b is equal to 1 from this information. Then I will compute f secant of x. So I will differentiate this function here, the f prime. So derivative of sine is cosine multiplied by minus a, so it's minus a cosine. And derivative of cosine is minus sine. Don't forget that we have these two rules, cosine x prime, that's minus sine, and sine prime, that's cosine. Briefly like that to remember the derivative of these two trigonometric functions. So here again, it's b minus b sine x. Okay, so minus b sine x, then f secant of 0. So I will substitute here, it's x here, x by 0. So this will be 0, and this will give cosine will give 1. So minus a multiplied by 1, this is equal to minus a. And from the information that f secant is equal to -1, this is equal to -1. That will give me that a is equal to 1. So b equal to 1 and a equal to 1. So the answer here is, let me remove this. The answer is A for this question. Okay, next, the second MCQ. So given that g of x is equal to 2 sine multiplied by a cosine, we want to find the derivative. This is easy question. We will apply the derivative rule, the product rule, sorry. So it's equal to 2. This is constant multiplied by a function, so it is kept multiplied. And derivative of this product, sine times cosine, I will have two terms. So sine x prime multiplied by cosine plus sine x multiplied by cosine prime. Okay, so sine multiplied by cosine prime. And now easily I will get 2 multiplied by cosine x multiplied by cosine x, that's cosine squared, plus sine x multiplied by minus sine x. So that's 2 cosine square x minus sine square x. And if you remember from trigonometric identity or definition, cosine square minus sine square, this is exactly cosine 2x. So the answer is equal to cosine 2x. That means the answer is C here. Okay. Now we can move to MCQ number 3. F prime of x here. I will apply the quotient rule. So I have the denominator squared, 1 plus cosine x squared. And in the numerator, so derivative of 1 plus sine x, derivative of 1 is 0, and derivative of sine, that's cosine, multiplied by the function in the denominator without derivative. And then that is minus the first one without derivative, 1 plus sine x, multiplied by the derivative of 1 plus cosine x. Derivative of 1 is 0, and derivative of cosine, that's minus sine. So you see here minus sign, and there is minus, it will be plus. So it is equal to 1 plus cosine x squared, cosine x plus cosine square x. So this is like plus, if we forget these two minus, so it's plus sine x plus sine square x. And you see that clearly cosine square plus sine square, that's equal to 1. So it's 1 plus cosine plus sine over 1 plus cosine squared, and the answer is B. Okay, now next to go to MCQ number 4. We want to calculate the second derivative of the function ex sine x. So let's say y is equal to ex sine x. Then the first derivative y prime is equal, this is the product rule. So ex derivative, it's the same. And multiplied by sine x without derivative plus ex, the derivative of sine, which is cosine. So in total, I will have ex times sine plus cosine. Good. Then the second derivative, y second, again the product rule. So it's ex derivative, it's the same, multiplied by sine x plus cosine x without derivative, then plus ex multiplied by the derivative of sine plus cosine. Derivative of sine is cosine, and derivative of cosine, that's minus sine. And then I can put ex common factor. So you see here, I will have sine x plus cosine x plus cosine x minus sine x. So there is simplification with sine, and I will get 2 cosine x multiplied by ex, or 2ex multiplied by cosine. So the answer is again B. And now we will move to essay question. And we compute the limits. Remember that I have this is small recall here, R. When I write R like that, it's recall of the formula in the lectures. So limit sine x over x in general when x approaches 0, this is equal to 1, and limit 1 minus cosine, or cosine minus 1 over x when x approaches 0, this is equal to 0. This is the two fundamental limits which are obtained using the derivative. So I will use these two limits to compute the number 1. So limit when x approaches 0 of sine 4x over sine 6x. This is kind of using the limit number 1 twice. So I will write it in the following way. So sine of 4x, I need to apply the rule here. I need to divide by 4x by the same theta inside the sine. So if I divide by 4x, I will make the correction, then I multiply by 4x. And again, here I will continue with the times over sine 6x. Also, for this, I will need divided by 6x. But again, here, I will make the correction of this division by sine x. I will write it here. It seems not clear. So 1 over sine 6x divided by 6x and multiplied here in the denominator by 6x. So in total, you see here, this is approaching 1 when x approaches 0. And also, this is approaching 1 when x approaches 0. So in final, I will have something like limit. It's somehow equal to that for x over 2 6x. Then simplify by x, it's 4 over 6. So 2 over 3. That's the limit number 1. Okay. Then number B. Okay. Number B, it's 1 minus cosine over x squared. More space here. Okay, so limit B, limit 1 minus cosine over x squared when x approaches 0. So in fact, I will use the second rule, which is limit of 1 minus cosine over x. This is equal to 0. And in fact, I will use a simple idea that I can here multiply 1 minus cosine x by 1 plus cosine x and divide by 1 plus cosine x. Okay, times x squared. So in the numerator, I will have 1 minus cosine squared over x squared times 1 plus cosine x. Okay, but 1 minus cosine x squared, this is equal exactly to sine squared. So this is limit x approaches 0, sine squared over x squared 1 over 1 plus cosine. Okay, so this is, you know, that this converges to 1. And the second part, when x approaches 0, this is converged to half. So 1 times half, this is equal to half. Okay. And that's the final answer for B. Let me see if we have another example. Yes, there is this C sine x squared over x when x approaches 0. So limit sine x squared over x when x approaches 0. It's easiest to write in the following way. limit x approaches 0, sine x squared. You should have the same thing as in the sine, so you divide by x squared, and you multiply by x to get this x in the denominator. You know that this quantity is converging to 1. This is converging to 0, so the result will be 0. Okay, now we can move to question 2 in essay question. Look here at the function, and we want to differentiate this function. So f prime of x, this is quotient rule, equal to tan squared. And in the numerator, its derivative of 1 is 0. Derivative of minus second is equal to, you remember this in the formula. I will recall the formula here. The derivative of second is equal, this is the, I can recall the formula, second prime is equal to secant tan, secant multiplied by tan. So here I will have minus secant x multiplied by tan x, and in the formula of quotient there is minus here, and the function in the numerator is without derivative multiplied by the derivative of tan, and derivative of tan is sine over cosine, so it is equal to, you can remember this by doing quickly if you don't recall it by heart. So it's sine over cosine prime, so it is equal to secant square. Okay, that's the recall here. So I will put here secant square of x. That's the derivative of, no, I will have over tan squared and minus secant multiplied by tan. So it's like minus secant squared x multiplied by sine, because tan is sine over cosine. It means sine times secant, and then minus secant squared plus secant cube of x. Okay, now we can simplify a little bit. I'll just make some space. Sorry, here there is a square is missing here. So this is tan squared. Okay, I can maybe simplify a little bit this quality here. We'll take advantage of the simplification by tan squared. So I will have, if I separate this, then this is minus secant x. And don't forget that this one also is divided by tan squared. So it will give me minus minus 1 over minus 1 minus secant x, and it should be multiplied by secant squared, but divided by tan squared. But tan is cosecant squared times over tan squared. It means that we can multiply by cosine squared instead, and also by cosecant squared. So in total, I use the fact that this 1 over tan squared can be written like cosine squared times cosecant square. Now you can verify this easily by writing the definition of tan in terms of sine and cosine, and use that the fact that 1 over sine is cosecant. So it will give me here cosine square multiplied by secant square, that's 1, and only cosecant square. Okay, now I can write, there is minus cosecant square x by expanding these with this minus, and then plus secant x multiplied by, in factor, secant x cosecant square minus 1. But cosecant square minus 1, this is exactly equal to cotan square. So I can just move a little bit down. So I will have equal to minus cosecant square x plus secant x cotan square x. This is the third identity in the trigonometric identities. But secant multiplied by cotan square, that's if you replace secant times cotan, that's like 1 over cosine times cotan square here, times cosine square over sine square. So there is this square with this cosine will disappear, and I will have cosine times cosecant square. But there is secant here, so the cosine with the secant gives 1, and then I will have cosecant square x. So it's minus cosecant square x plus. So here I have what I find here is that cosecant square times cotan. So there is cosine over sine. That means cotan x times cosecant x. This is exactly what we found here when we multiply by secant. So it will give, sorry, by secant, yes, that's true. So the cosine, this cosine will disappear with the secant, and then I will have, that's what we did here with this secant, sorry, no need to multiply. So I will have cosine, in fact, divided by sine squared. And this you can write it like cosine over sine multiplied by 1 over sine. That's exactly cotan times cosecant. That's what we found here in this formula. Okay, so that's cotan times cosecant here. It's tricky a little bit, but you can find the derivative at the end. Now, question 3, we want to find the 17th derivative of x times cosine x. So as usual here, you will start by computing the first derivative and see what happens. So this is product rule, and I will have cosine x minus x sine x, since the derivative of cosine is minus, then y secant, this is minus sine. And here you have the product rule in this second term. So I will have minus sine x and minus x cosine x. So in final, I will have minus 2 sine x minus x cosine x. If I go to the third derivative, then I will have minus 2 sine x. Then apply the product rule for this one, minus cosine x and plus x sine x. Okay, So I will have minus 3 cosine x plus x sine x. So we didn't return to the original function, which is x cosine x. It will be in the next step. So fourth derivative of this will give 3 sine x. Okay. Now plus sine x, the derivative of x is 1, and then plus x cosine x. And you see here that we find that it is 4 sine x plus x cosine x. Here is the original function y. Okay, so I can conclude that we have a kind of pattern of fourth periodicity. So since we want 17th, that means y 17th is like y prime, since 17 is equal to 4 times 4 plus 1. Okay, so it's like y prime, and y prime will give, but of course, somehow it's not exactly like, but we can conclude the y prime, the y 17 from y prime. Okay, so it's not equal, be careful here, but it is somehow concluded from the y prime. So that means, why I say that? Because you have this number which appears with the order. You have order 3, then you have this number, and you have plus minus sometimes, okay? So be careful of that. If I want to compute, so the 17th derivative, I will have for sure this order 17 somewhere here, and it's like y prime, so I will have cosine in the first term and minus x sine x, but of course there is this plus or minus that we will have from the derivative. So in final, I have to find that. And of course, this is the 17th derivative of y, because as I said, 17 is 4 times 4 plus 1. So it's like we return to this derivative, but there is a little modification in the coefficient in front of the cosine, since we saw in the pattern that there is this number which represents the order of derivatives. So we have 17, and that's the finish. And so thank you so much. This is the end of this worksheet.